Hello, class. This will be the second part of the recorded lecture for section 5.1. And we're going to talk about calculation of probabilities now using data. And that's where the statistics part comes in. And so this idea of, first of all, they call this a probability experiment, but it's actually collecting data. And so I'll show you one example here using the screen or the PowerPoint slide. And the second example I'm going to show you using spreadsheet. So this one has 10,000 families, and they did a survey of where people live. Own a house, own a condo, rent a house, rent an apartment. I'm in the own a condo portion right now. So remember, when you calculate probability, the total, the end value, right? The total in our sample is 10,000. That always goes in the denominator. And what goes in the numerator is the success. And so the first question says, find the probability of a family owning a house. So what we have down here in the denominator is 10,000. And what we have up in the numerator would be the 4,753. And in this case, we do the division, and you can see it's 0.4753. So be careful, look at the problem, and it's very picky about rounding to the right decimal. So make sure you take a look at that, and I'll show you how the spreadsheet can help you with that as well. Problem B here, the probability of renting. So you can see that there are two columns here for renting, right? So the probability of success would be either renting a house or renting an apartment. So in that case, that's why we're adding those two together to put into the numerator. And you can see the denominator equals 10,000, do the division. And you can see it's a little over, or a little under 38%, 0.3769. So here's another example. Here's a list of bachelor's degrees at a local college listed by major. And so what I did in this case is stuck this data in a spreadsheet, and to show you how to do the calculations of a spreadsheet. And so if you were doing that, the calculations of the spreadsheet gives you the ability to not only do the math or pretend like it uses as a calculator, it also will do rounding for you too, which I'll show you. So the first question was, what is the probability of engineering? And so remember, equal sign to get the equation started. And so what's in our numerator? Well, the probability of success would be 868. So you just highlight B8, hit division, and I did the total here. And so the total would be B9. And you can see that it's just about 10%. How do you do the rounding? Well, let me show you that. You could format this cell. It's called formatting cells. And I right-click my mouse, but there's other ways to get into it. And I use the numbers. And so you can see here that it'll give you the total number of decimal points that it's going to display, and it does the rounding for you. So if you needed more, you'd go 5 or 6, or if you needed less, you can go 2 or 3. So let's go to 5 to show you that you can expand it out, and that would be the 5 decimal points. So what if you were looking for the probability of, say, the STEM? So that is science and engineering and math and technology. And so you look at here, and we would have 3 of those. It would be the mathematics, 4 of them, excuse me, mathematics, chemistry, physics, and engineering. So how do you do that? So what we do here is we, first of all, we need to, in the numerator, we have to add all those together. So that would be the math. So start with the parentheses because we want to add all the denominators first before we do the division. And then it would be chemistry, and then it would be physics, and then it would be engineering. n parentheses, and then you want to divide by the total. And you can see that it's just under or just over 45% or 0.4516. So the last thing I do want to talk about is this idea of unusual, or even more better word, I think, is unlikely events. Is that something that probably won't happen? And what the book uses is this rule of thumb of 0.05 is considered unusual. I think the better word for it is unlikely. And so if you have something that's 5% or less, it's very unlikely that it's going to happen. And so here's an example of 500 students, and there's 150 math majors. So if you do that calculation probability-wise, 150 divided by 5,000 is only 0.03 or 3%. And that would be considered, and the book uses the word unusual, I would use the word unlikely with regards to that. And so that's important to understand too, that if something is only a 1% or 0.5%, it's probably not going to happen. And that's what we mean by unusual or unlikely. So that finishes the recorded lectures for section 5.1.